It's 2100. The last commercial oil well went offline 7 years ago, not because we chose to stop, because there was nothing left worth drilling. The world didn't end, but it changed in ways that would shock anyone living today. Over the next 10 minutes, we're going to take you there, sector by sector, resource by resource. This is what science, data, and current trends suggest our planet will look like 74 years from now. Let's start with the biggest story of the century. In 2026, fossil fuels, coal, oil, and gas, still powered about 80% of the world. By 2100, less than 1%. That's not a typo. Here's what fills the gap. Solar and wind, combined, will account for roughly 62% of all energy. The math is simple. Sunlight and wind are free. And by mid-century, generating them became cheaper than literally anything else in human history. But the wild card? Nuclear fusion. The energy technology that's been 20 years away for 70 years actually arrived. By the 2050s, the first commercial fusion reactors came online. By 2100, they supply 18% of all global electricity. Clean, virtually unlimited. No meltdown risk, no long-lived radioactive waste. The energy crisis humanity feared? It didn't happen. The real crisis turned out to be everything else. Here's the irony no one talks about enough. Building a clean energy world requires an enormous amount of mining. Solar panels need silicon, silver, and indium. EV batteries need lithium, cobalt, and nickel. Wind turbines need rare earth elements like neodymium and dysprosium. In the 2030s and 2040s, this triggered a new kind of geopolitical scramble. Not for oil fields, for mineral deposits. But by 2100, three things changed the game completely. 1. Urban mining. The billions of smartphones, laptops, and EVs that had already been built became the ore bodies of the future. By 2100, 45% of all critical minerals come from recycling, not from the ground. 2. Deep sea mining. The ocean floor turned out to be studded with manganese nodules and cobalt-rich crusts. Controversial, regulated, but real, supplying 27% of what the world needs. 3. And this one sounds like science fiction, but it isn't. Space. By 2100, over 340 commercial space mining operations are active. Asteroid mining for platinum group metals began commercially in the 2070s. The effect on platinum and rhodium markets was historic. Prices collapsed by over 80%. Land-based mining, what we do today, accounts for just 10% of supply. The lithium under the salt flats, the cobalt in the Congo, still important, but no longer the whole story. Of everything we'll discuss today, water is the one that should keep you up at night. By 2100, 67 countries face what scientists classify as severe water stress. That means 40% of the world's population, billions of people, living where demand consistently outstrips supply. Rivers that billions depend on are at risk. The Nile, the Indus, the Mekong. As glaciers retreat and rainfall patterns shift, the nations sharing these waterways are in constant negotiation. Sometimes, tense standoff. So how does the world drink? Desalination, turning seawater into freshwater, now supplies 38% of the global freshwater used in homes, farms, and factories. It's energy intensive, which is why it's only viable because of cheap, clean electricity. But here's the technology that genuinely surprised even experts. Atmospheric water generation. Machines that pull water directly from air, even in relatively dry climates. By 2100, 25% of drinking water in water-stressed regions comes from the sky. The remaining supply comes from wastewater recycling, 22%, and what's left of natural freshwater systems, just 15%. Water is no longer free. It's priced, traded, and in some regions, it's fought over. It is, without question, the most contested resource of the 22nd century. Quick, name the resource that's most essential to human survival. Most people say oil or water. The correct answer is phosphorus. Phosphorus is an element that plants need to grow. There is no synthetic replacement, there is no alternative. Without phosphorus, agriculture collapses. Without agriculture, civilization collapses. Today, we mine phosphate rock, and we waste most of it. It runs off into rivers. It ends up in the ocean. And the world's known economically viable reserves are projected to hit their limits by the mid-21st century. This is arguably the least discussed existential resource crisis in public conversation. By 2100, the solution is almost entirely circular. Phosphorus is recovered from sewage, yes, really, from agricultural runoff, and from food processing waste. Technology that would have seemed absurd in 2026 is now standard practice everywhere. There's also extraction from deep-sea hydrothermal deposits, still in early stages, but critical. The phosphorus crisis was quietly solved, not with a single breakthrough, but with 1,000 boring infrastructure decisions made over 70 years, which is often how the most important problems get fixed. Food production is one of humanity's oldest industries. By 2100, it looks almost nothing like it did in 2026. Three forces drove the transformation. First, climate change made traditional agriculture increasingly unreliable. Heat waves, floods, droughts, the old growing regions shifted, and new ones opened up. But farmland overall became less predictable. Second, a population of over 10 billion people needed to eat, and eat well. Third, we simply ran out of new land to clear. So food went vertical. Controlled environment agriculture, indoor farms with LED lighting, hydroponic systems, and AI-managed climate control, now produces 40% of global food supply. No pesticides, minimal water, year-round production regardless of weather. Located in or near cities, cutting transport emissions to near zero. Then, there's cellular agriculture, meat, grown from animal cells in a bioreactor without slaughtering a single animal, fish, poultry, beef. By the 2070s, it became price competitive. By 2100, it accounts for 30% of all protein consumed globally. Traditional agriculture isn't gone. It still provides 22% of food, but it's leaner, smarter, and far less destructive to ecosystems. And livestock farming? It's shrunk to 1/5 of what it was in 2026. One of the biggest reductions in land use in human history. Here's a fundamental shift. In 2100, most developed economies don't think of things as disposable because they can't afford to. In the wealthiest nations, 85% or more of all materials, metals, plastics, glass, textiles, are recovered and reused. AI-driven sorting systems can identify and separate over 200 material types in seconds. Your old phone isn't trash, it's a mine. The International Resource Sharing Agreement of 2068, signed by 134 countries, mandates minimum recovery rates across product categories. It changed supply chains globally. But there's a gap. The countries that produce the most waste per capita tend to be the ones with the best recovery infrastructure. Hundreds of millions in the developing world still don't have access to proper recycling systems. That remains one of the great unfinished challenges of the 22nd century. So here's the picture. By 2100, humanity has solved some of its oldest problems in ways that would seem like science fiction today. Virtually unlimited clean energy. Food production that doesn't destroy the planet. Materials that cycle endlessly rather than piling up. And yet, water is more contested than ever. Billions still lack stable access to basic resources. The gap between the world's richest and most vulnerable communities hasn't disappeared. It's just wearing different clothes. The story of resources in the 22nd century isn't a story of triumph or catastrophe. It's a story of transformation, of technologies that arrive just in time, and political failures that cost millions of lives, of problems quietly solved by engineers no one remembers, and crises still unfolding. The choices made in the next 20 years will determine which version of this future we get. That's not dramatic. That's just what the data says. If this gave you something to think about, the subscribe button is right there. And drop a comment. Which resource do you think is the most underrated threat? Let's talk.